Jai Shri Gurudev. Good morning to everyone, students. Welcome to chemistry class. In the previous class, we studied about octet rule, then Lewis dot structure along with some examples, then the definition of formula charge and formula to calculate the formula charge of an atom in a molecule or compounds. Okay, these are the things we are studied in the last class. In this class, we are going to study the limitations of octet rule. Okay, that is the limitations of octet rule. So here there are some limitations of an octet rule. Now the first limitation is the incomplete octet of central atom. The incomplete octet of central atom. It means the central atom do not having 8 electron around it, that we call incomplete octet of central atom. Some of the elements like beryllium, boron and lithium, these do not having 8 electron around it. However, in their valence shell having only 1, 2, 3 electrons in lithium, beryllium and boron respectively, so that around that there is no 8 electrons. That is, see the example, the elements like lithium, beryllium and boron. Beryllium and boron. See, the atomic number of lithium is 3, beryllium 4 and boron 5. In the outermost shell, there is only 1 electron in lithium and beryllium having 2 electrons, then boron having 3 electrons. Some of the compounds of these elements, let me have take the example lithium chloride. Take it for the lithium fluoride, and for beryllium take beryllium hydride. Then take for boron trifluoride or boron trichloride, etc. So these are some examples we are taking. So you know, when in lithium there is only 1 electron in outermost shell. So that is, you know, by the electronic configuration. See, lithium, the atomic number is 3 and the electronic configuration is 1s2, then 2s1. This is the outermost shell having only 1 electron, right? So that it has ability to make only 1 bond with a neighboring atom or with any other atom to attain octet rule. But only in the presence of 1 electron in lithium, it make 1 bond with fluorine. In this case, fluorine is completely filled in their outermost shell. It means it obey 8 electrons, octet electron rule, but lithium 5. Okay, that is the limitation. Similarly, you see the structure of lithium fluoride by writing in the Lewis dot structure is there is a lithium having only 1 electron. And fluorine, you know, in the fluorine there is 7 electrons around that. That is 2, 3, 4, 5, 6 and 7 electrons. Now these two make a bond. In this case, the lithium fluorine having 8 electrons around that, 8 electrons, but the lithium having only 2 electrons. Okay. Now here the lithium 5 to obey 8 electrons. Similarly, take beryllium hydride. You know, beryllium atomic number is 4. So the electronic configuration is 1s2 and 2s2. See here, the second orbital, that is 2s shell is completely filled. After 2s, there is a 2p empty orbitals. Now in the excited state, one of the electron from s to p jumps. During that time, there is 2 lone pair electrons, 2 unpaired electrons. Those two make a bond with the neighboring atom. Hence, it make a bond with 2 hydrogens in this compound. In this case, see the structure of beryllium hydride is beryllium. It having 2 electrons in their outermost shell, beryllium. Now hydrogen, its atomic number is 1. There is only 1 electron. Now it means the hydrogen to make noble gas configuration, a stable electronic configuration, it should need one electron. After gaining one electron, it will be stable helium noble gas configuration. Hence, it makes bond with the beryllium. And similarly, this hydrogen also makes bond. Now here, this hydrogen is stable helium noble gas configuration. These two hydrogens having one. But this beryllium having only 4 electrons, it still need 4 electrons to obey octet rule. Now here around boron the electron is deficient. Similarly, now take beryllium. So the beryllium is this one. Now take boron. So in this case, we are taking boron trifluoride or boron trichloride. Anyone you can take. In this boron, the electronic configuration is 1s2, 2s2 and 2p1. Okay, this is the electronic configuration. See here, there is only 3 electrons around the boron. So boron having 3 electrons around that, it has ability to make 3 bonds with the neighboring atom. Now here we are taking fluorine. The fluorine is deficient, only 1 electron to attain next noble gas configuration. That is helium configuration, so neon configuration. Okay, therefore this fluorine make only 1 bond with boron. Around that there is 6 electrons remaining. Only 1 electron is make bond. In this case, see the fluorine having 8 electrons. Similarly, one more fluorine make bond with the other electron of boron. Similarly here, around that fluorine there is 6 electrons. 1 electron only make bond with boron. Here also. Now observe in this case, the fluorine having 8 electrons, but boron do not have it. It having only 6 electrons. So in this case, what we are saying, the central atom like lithium, beryllium and boron, these 3 do not having 8 electron around that valence shell that we called the incomplete octet of central atom. Okay, then the second limitation is hard electron molecule. See, it means the molecules like nitric oxide, nitrogen dioxide, etc. These elements do not having 8 electrons. Any one of the element among these molecules because this having odd number of electrons. Now see, you know the nitrogen having 5 valential electrons in their outermost shell and oxygen having 6 valential electrons in their outermost shell. Okay, that you know by writing the electronic configuration. No need to write the electronic configuration every time to explain here. I hope you understanding. So just see, for NO I am explaining means nitric oxide. Here nitrogen, the atomic number is 7. Then the electronic configuration is 1s2, 2s2 and 2p3. 3, that is 3 plus 2, 5 plus 2, 7. Similarly, take oxygen, the atomic number is 8, the electronic configuration is 1s2, 2s2 and 2p2. 2p2 or 4, that is 4 plus 2, 6 plus 2, 8. This is the outermost valence shell. See here, there is 5 electrons and here 6 electrons. That is 5 for nitrogen and 6 plus 6 for oxygen. Totally becomes 11 electron for nitric oxide. In this case, write the Lewis dot structure. N oxygen. So there is 11 electrons. Fill the 11 electrons. For nitrogen, for oxygen, 6 electrons. 6 electrons. 1, 2, 3, 4, 5, 6. Then for nitrogen, 5 electrons. 1, 2, 3, 4 and 5 electrons. Now see here, around oxygen there is 8 electrons. 8 electrons like that. And around nitrogen there is only 5 electrons. 5 electrons. Around nitrogen 1, 2, 3, 4, 5, 6, 7 only. If you share these 2 electrons around with nitrogen. See, if these electrons of oxygen shares with the nitrogen, that is 2 electrons. Now, if nitrogen oxygen makes double bond, then the nitrogen has only 7 electrons. 4, 5, 6, 7. That is hard electron. Any one of the atom among these two satisfies octet rule. That is the limitation, that is hard electron hole. Similarly, here observe NO2, that is N, O and O. The nitrogen having 5, each oxygen having 6, totally there is 12 electrons. 12 plus 5, that is 7 electrons. Sorry, 17 electrons. Here also hard number of electrons. So now write the structure of NO2, N, oxygen and oxygen. Nitrogen having 5 electrons. See, the 5 electrons is writing like that, 5. And oxygen having 6 electrons, each oxygen. 2, 3, 4, 5, 6 around oxygen. Similarly here, 2, 3, that is 6. 4, 5, 6. Now here around this nitrogen there is 6 electrons. So if oxygen is 8 electrons and around this oxygen also 8 electrons. But this nitrogen only one lone pair electron is one hard electron is possible. Hence this is also unstable one. And this nitrogen atom do not obey 8 electrons. Hence these odd number of electrons to attain stable, they undergo dimerization. Here the NO2 molecule undergo dimerization and form N2O4 molecule like that you studied in the 3 block elements. This is the hard electron configuration. Then the third limitation is expanded octet bond. The third limitation is expanded octet bond. The elements of third and higher period elements having d orbitals along with s and p orbital. Third and higher period. You know, in the periodic table when we are going to the after first and second and third period, this third period and fourth period means after third and fourth period elements. It means d block elements and the respective or corresponding s and p block elements having the d orbital along with s and p orbitals. So here it exceeds greater than 8 electrons around that. For example, some compounds you take phosphorus pentafluoride or sulphur hexafluoride, etc. Now in these compounds are taken H2SO4 sulfuric acid. In these compounds the central metal atom or the central element is phosphorus, sulphur and here also sulphur. These elements having greater than 8 electrons around that we call expanded octet bond. It means it leads greater than 8 electrons. Now observing these structures of the molecules, phosphorus pentafluoride, the central metal atom is phosphorus. It has 5 valential electrons and there is 5 fluorine atoms. 1 fluorine atom, second, third, fourth and fifth, there is fluorine atoms. So here observe around that phosphorus there is 5 bonds. Each bond is formed by sharing 2 electrons, right? 2 electrons, see? 2 electrons. Now this fluorine having 8 electrons. The outer shell electrons is 6 plus 1 is make bond with fluorine. So phosphorus. Total it has 8 electrons. All these 5 fluorine satisfies octet bond, but this fluorine is exceeded or expanded, that is called greater than 8 electrons. Around 5 plus 5 electrons from each fluorine atom donate 1 electron, that is 5 electrons from 5 fluorine atom. Totally 10 electrons here. There is 10 electrons. Now take sulphur hexafluoride. That is sulphur hexafluoride. This is the structure sulphur hexafluoride. That is 4 fluorine atoms are equatorial position. These 4 fluorine atoms are equatorial position and these 2 fluorine atoms are axial position. So see here, this is the structure of sulphur hexafluoride. Now around sulphur there is 6 bonds. 6 bonds means 12 electrons. Each bond is formed by sharing 2 electrons, right? So there is 12 electrons. Similarly, take H2SO4, write the structure of sulfuric acid. You know, in your lower classes you studied So sulfuric acid structure is sulfur and 2 hydrogens and 4 oxygens, that is OH bond OH. Then how many oxygens are left? 2 oxygens. Those 2 are divalent, make a bond with oxygen, that is dibonded, means double bonded. So observe here, around the sulfur 1, 2, 3, 4, 5, 6. 6 bonds is there. 6 bonds means 12 electrons. In these compounds exceed greater than 8 electrons, that is called expanded octet group. Okay, when the d orbital is present in a molecule or compound, those exceeds octet group. Then the fourth limitation is the octet group is based on the inertness of noble gases is explained. However, some noble gases like xenon, krypton are formed compounds with fluorine or some other elements that fails to explain this octet group. ಅಂದ್ರೆ ಆಕ್ಟೈಡ್ ರೂಲ್ ಅನ್ನೋದು ನೋಬಲ್ ಗ್ಯಾಸಸ್ ನ ಇನರ್ಟ್ನೆಸ್ ಮೇಲೆನೆ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ದು. ಇನರ್ಟ್ನೆಸ್ ಅಂದ್ರೆ ನೋಬಲ್ ಗ್ಯಾಸಸ್ ನೋಡ್ಕೊಳ್ಳಿ, ಅಂದ್ರೆ ಹೀಲಿಯಂ, ನಿಯಾನ್, ಆರ್ಗಾನ್, ಕ್ರಿಪ್ಟಾನ್, xenon except helium, rest of the all noble gases having 8 electrons around that, right? So that there is no vacant orbitals to form a bond with other elements. On that base only the octet rule is explained. But some noble gases like xenon and krypton, example, some noble gases like xenon and krypton form a compounds. For example, see xenon difluoride or krypton difluoride or xenon tetrafluoride oxide compound or xenon hexafluoroplatinum. See, xenon hexafluoroplatinum, xenon tetrafluorooxide, krypton difluoride, xenon difluoride. These compounds are some examples, those formed compounds of xenon or noble gases compounds. Okay, so here the octet rule is 5. Then the fifth one, this theory fails to explain the relative stability of any compounds. Relative stability of any compounds. It fails to explain relative stability of any compounds. For example, I told you NO2, nitrogen dioxide. This having odd number of electrons, right? We are studying example in hard electron molecule. So it doesn't exist as NO2, rather than it exists N2O4 like that. This is the stable molecule. It fails to explain why the nitrogen dioxide is exist as N2O4. Okay, or diborane, you know, B2H6. Diborane B2H6. Actually, this molecular formula is BH3. This is the boron hydride. It doesn't exist. Rather than it exists as B2H6. It fails to explain these concepts. Okay, that is called, it fails to explain the, this theory fails to explain the relative stability of some molecules or compounds. Then next one, this theory doesn't explain the shape of the molecule. It fails to or doesn't explain shape of the molecules or compounds. Shape of the molecules or compounds. For example, see in the some examples I given in the expanded octet rule, that is phosphorus pentafluoride or sulphur hexafluoride or sulphuric acid, etc. So see here, I write the structure of phosphorus pentafluoride, that is this one. This is the structure of phosphorus pentafluoride, right? So its shape is square pyramidal. See, this is the square and this is pyramid. So its shape is square pyramidal. And this is hexafluoride, sulphur hexafluoride, that is sulphur 6 fluorine atoms, right? These 2 fluorine atoms are axial and remaining 4 fluorine atoms are equatorial. See, this is in one plane and these 2 are above and below. So this is called octahedral. And this is also sulphuric acid, also square pyramidal that we are called, right, like that, SOH, OH, double bond O. So this is the square. These are the shapes of the compounds or molecules. This doesn't explain this octet rule. So these are the some limitations of octet rule. Okay. Now what are the limitations of octet rule? What are the limitations of octet rule? The first one is the incomplete octet of central atom. That is, there is no 8 electrons around the atom. Then hard electron molecules means the elements those having or the compounds those having hard electrons. Among those, any one of the atom do not having 8 electrons. Then expanded octet rule means some of the element, that is third and higher period elements having d orbitals, those exceeds it means greater than 8 electrons. Then next one, it explained based on the inertness of noble gases. However, some noble gases like xenon and krypton, they form a compounds with fluorine or some other elements. Okay, so that it fails to explain octet rule. Then it doesn't explain the relative stability of a compounds. Example, we are taking dichloride or dimerization of nitrogen dioxide, etc. Then it doesn't explain the shape of the compounds or molecules. That is, we are studying sulphur exochloride and sulphuric acid and phosphorus pentafluoride. Those shapes are square pyramidal and octoidal and square planar. It doesn't explain by octet rule. Okay, these are the limitations. The next concept is ionic or electrocovalent bond. So you already studied the covalent bond, right? Similarly, this is the second type of bond, that is ionic bond or electrovalent bond. See, the ionic bond is found between the two charged ions. These charged ions is formed by complete transfer of valential electrons from one atom to another atom. The electron may be either one or more than one electrons. So that the ionic bond is defined as, or the ionic bond is, or the definition of ionic bond is the sharing of one or more electrons between two atoms in order to attain two charges, that is positive and negative charges. Between those two charges, the electrostatic force of attraction is exhibited, that leads to formation of bond. That resulting bond we called as a ionic bond. Okay, so ionic bond is formed between two atoms. So ionic bond is defined as the transfer of valential electrons from one atom to another atom in order to attain 8 electrons in their outermost shell. So this is called the simple definition of ionic bond or electrocovalent bond. So here remember, the electrons is transferring from one atom to another atom. It may be either one electron or more than one electron. Now for example, and the ionic bond or electrovalent bond is formed only between two charged ions, that is oppositely charged ions. One is positive and one more is negative. Now for example, take sodium chloride. This is the salt. Okay, between sodium and chlorine atom there is a ionic bond or electrovalent bond, not covalent bond. Now you know the atomic number of sodium is 11 and the atomic number of chlorine is 70. Okay, write the electronic configuration: 1s2, 2s2, 2p6 and 3s1. This is for sodium. Okay, that is 8 plus 2 10 plus 1 11. Then similarly for chlorine, 1s2, 2s2, 2p6, then 3s2, 3p6, right, or 5, 3p5, 5, 6, 2, 2, 4 plus 6, 10, 10 plus 7, 70. So here the valence shell having 7 electrons and this one having only 1 electrons. Now to attain 8 electron, the sodium it loses 1 electron to the chlorine. During that time, the 3s shell is completely disappears, and the inner shell, that is 2s2 and 2p shell, that is K-L shell, having 8 electrons. Okay, at that time stable near noble gas configuration. Now after gaining chlorine 1 electron from sodium, it attains positive negative charge. During that time, it also obeys the stable noble gas configuration of krypton. After fluorine, next one argon, not krypton, argon noble gas configuration. Okay, during that time the sodium carries positive charge and chlorine carries negative charge. See, this sodium having 1 electron, this 1 electron is transferred to the chlorine, then here 5 becomes 6, and here 1 electron is loses, so that it carries positive charge. After gaining 1 electron, it carries negative charge, means the sodium becomes sodium ion by losing 1 electron. Okay, then similarly the chlorine becomes chlorine ion by gaining 1 electron from sodium and becomes chlorine ion minus ion. Now this chlorine ion and the sodium ion both are oppositely charged ions. One is positive and one is negative. Between these two means between sodium ion and between chlorine ion, negative ion, positive, cation and anion. Between these two there is a electrostatic force of attraction. This is called as electrostatic force of attraction. ಅಂದ್ರೆ ವೇಟ್ ಮತ್ತೆ ಏನೋ ಒಂದು ಫೋರ್ಸ್ ಇದೆ ಅಂತ ನಾನು ಈ ತರ ಬಾಂಡ್ಸ್ ಹಾಕಿದ್ದೀನಿ. ಆ ಫೋರ್ಸ್ ಏನಾಗುತ್ತೆ ದಟ್ ಲೀಡ್ಸ್, ಅದು ಏನಾಗುತ್ತೆ ಫಾರ್ಮೇಷನ್ ಆಫ್ ionic bond ಅಥವಾ electrovalent bond ಫಾರ್ಮೇಷನ್ ಆಗೋದಕ್ಕೆ ಹೆಲ್ಪ್ ಆಗುತ್ತೆ. This is the electrovalent bond or ionic bond definition and example. Similarly, you can observe the electrocovalent bond or ionic bond in calcium fluoride also. Here the calcium atomic number is 20 and the fluorine atomic number is 9, right? In calcium, the outermost shell having 2 electrons, and the fluorine having outermost shell 7 electrons, right? The fluorine should need only 1 electron to make a bond, and similarly the calcium need 2 electrons because the outermost shell having 2 electrons, it has the ability to make a bond with 2 atoms or 2 bonds with any one atom. Okay, so that these two are shared with another fluorine atoms. In case of calcium difluoride, during that time between these two electrostatic bond is formed. It transfers or it loses its outermost valence shell electrons, both the electrons. ಇಲ್ಲೇನಾಗುತ್ತೆ ಕ್ಯಾಲ್ಸಿಯಂ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಲಾಸ್ ಮಾಡ್ಕೊಂಡಾಗ ಮಾತ್ರ ಇನ್ನರ್ ಶೆಲ್ ಅಲ್ಲಿ 8 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಆಗೋದು. ಅದಕ್ಕೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಅನ್ನು ಲಾಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟು ಫ್ಲೋರಿನ್ ಗೆ ಕೊಟ್ಬಿಟ್ಟಾಗ ಇದಕ್ಕೆ 2 ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಲಾಸ್ ಆಗಿರೋದ್ರಿಂದ 2 ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬಂತು. 1 electron gain ಮಾಡ್ಕೊತ fluorine, so it carries 1 negative charge. Each fluorine accepted again only 1 electron from calcium atom, so that it carries only 1 negative charge. Now 2 negative charge 2 fluorine atoms and 2 positive charge 1 calcium atom make a bond, or there is a force of attraction between these 2 atoms of fluorine to the calcium that leads to the formation of ionic bond in calcium difluoride. Okay, this is the details of ionic bond or electrovalent bond. Okay, right, definition. Then take the next concept is factors which influence the formation of ionic bond. Okay, you know what is mean by ionic bond and how the ionic bond is formed. That is complete transfer of valence shell electrons from one atom to another atom in order to attain 2 oppositely charged ions. Between them there is an electrostatic force of attraction that leads to the formation of ionic bond. Okay, that is the definition, keep in your mind. Now we are going to study the factors which influence the formation of ionic bond. The first one is the atom which ready to lose electron should having low ionization by enthalpy, so that it attain positive charge. The first one is the atom which is ready to lose electron having low ionization enthalpy, that is delta Hi, that is change in ionization enthalpy in order to attain or so that it attain positive charge easily, positive charge easily. Okay, so for example, take sodium ion. Okay, sodium having only one valence shell in outermost shell, so that by supplying small amount of energy, it ready to lose one electron and becomes sodium ion, that is positive ion. So that is attain positive charge ion. Then the second one is the atom or the element which is ready to gain electron that having high electron gain enthalpy. This one having low ionization enthalpy. The atom which is ready to gain electron that having high electron gain enthalpy, so that it is ready to or it is attain negative charge easily. That is the atom which is ready to gain electron having high electron gain enthalpy, that is EG, electron gain enthalpy, so that attain negative charge easily. Okay, got it, students? I hope you understanding what I am telling here. So attain what? Negative charge easily. Now for example, take a chlorine. To attain 8 electrons in outermost shell, gain electron easily. To gain this electron, it should need a high energy. See, it gain a high ionization electron gain enthalpy. So this one chlorine having high electron gain enthalpy, so that it form negative charge. That is Cl minus, here Na plus. Now the third point, see, between these two ions, between oppositely charged two ions having high electrostatic force of attraction to form crystal lattice which having high lattice enthalpy. These two having high lattice enthalpy, so that it should need high energy to form crystal lattice. That is, see, the two oppositely charged ions. The third point is two oppositely charged ions which are held, and these two having high electrostatic force of attraction. These two atoms having high electrostatic force of attraction. This is the, let assume force. Just I am writing like that. Between these two, there is a high electrostatic force of attraction to form crystal lattice, which should having high lattice enthalpy, that is indicated by U. These crystal having high lattice enthalpy, hence to form crystal lattice it should need high energy. They liberate high amount of energy. ಇದೇನಾಗುತ್ತಂದ್ರೆ ಒಂದು ದೊಡ್ಡ ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್ ಫಾರ್ಮ್ ಆಗಬೇಕಂದ್ರೆ ತುಂಬಾ ಎನರ್ಜಿನ ಲಿಬರೇಟ್ ಮಾಡ್ತಾ ಇರುತ್ತೆ. ಈ ಕ್ಲೋರಿನ್ ಅಯಾನ್ ಮತ್ತೆ ಸೋಡಿಯಂ ಅಯಾನ್ ಮತ್ತೆ ತುಂಬಾ ಎಲೆಕ್ಟ್ರೋಸ್ಟಾಟಿಕ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇರೋದ್ರಿಂದ, ಜಾಸ್ತಿ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಇರೋದ್ರಿಂದ ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್ ಫಾರ್ಮ್ ಆಗುತ್ತೆ. ಆ ಕ್ರಿಸ್ಟಲ್ ಲ್ಯಾಟಿಸ್ ಅಲ್ಲಿ ತುಂಬಾ ಇಂಟರ್ನಲ್ ಎನರ್ಜಿ, ದಟ್ ಇಸ್ ಯು, ಅಂದ್ರೆ ಲ್ಯಾಟಿಸ್ ಎಂಥಾಲ್ಪಿ. ದಿಸ್ ಇಸ್ ಕಾಲ್ಡ್ ಲ್ಯಾಟಿಸ್ ಎಂಥಾಲ್ಪಿ. Later you know what is the mean by our definition of lattice enthalpy. So that it having high lattice enthalpy, it means to form crystal lattice liberate large amount of energy. ಅಂದ್ರೆ NaCl ಅನ್ನೋದು ಒಂದು ಅಯಾನ್ ಅಂತ ತಗೊಂಡಾಗ, ಒಂದು ಚಿಕ್ಕ ಸ್ಮಾಲ್ ಕಾಂಪೌಂಡ್ ಅಂತ ತಗೊಂಡಾಗ ಒಂದು ದೊಡ್ಡ ಕ್ರಿಸ್ಟಲ್ ಆಗಬೇಕು ಅಂದ್ರೆ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸಿ in a chalk piece there is a small particles. To make such a big chalk piece, all amount of ions will be make a bond together and form a big chalk piece like that, right? Similarly, to form number of sodium chloride crystals. Let us assume this is one sodium crystal, that is sodium chloride crystal. To form large amount of sodium crystals like that. To form large amount of sodium crystals, it should liberate energy. Energy ಅನ್ನು liberate ಮಾಡ್ತಾ ಇರುತ್ತೆ. ನೆಗೆಟಿವ್ ಬರೀತಾ ಇದರಿಂದ heat ಅನ್ನೋದು liberate ಆಗ್ತಾ ಇರುತ್ತೆ. That is H is negative. Liberates large amount of energy, that we call energy liberated. Inside that there is a large amount of lattice. Okay, this is the factors which influence the formation of ionic bond.